Hi everybody, welcome back to Make the Grade. This is Tuesday. My name is Caroline Richardson, and for the next hour I'm going to be here to help answer your math questions. If you have some homework, and actually probably what's coming up for most of you is EOC test time. So what I'm going to do is I'm going to take the next 3 days, today, Wednesday, and Thursday from 4 to 5, and I'm going to keep reviewing questions on the EOC. I'm going to give you strategies on how to take the test. There's some problems that you don't even have to do much math if you can understand what the problem is and how they're asking you the questions. But I do want you, if you have something that you didn't understand what I'm going over, or if your teacher has given you some review problems and you're stuck on one, just give me a call. The number's going to appear across the bottom of the screen. Give me a call, and I will answer that question. I'll just take a break with the questions I'm working on, and I'll answer one of your questions, okay? Now, if you would like to follow along with what I'm doing, you can go to the Wake County website, which, let me pop this up here. The Wake County website is www.wcpss.net, and do a search for the EOC review, and the questions will actually be there under Algebra 1. Come back to me. Under Algebra 1, Geometry, and Algebra 2, there's some EOC review questions. Now, there are also some EOG questions there, because I know some of you, especially those of you who are on year-round, might not have taken some of your tests, or if you have to retake your test, if anything like that has come up, you need to go ahead and give me a call, and we'll go through those problems as well. All right, the number that you want to call me is going to come across the bottom of the screen, but if it doesn't, let me give it to you right now. Got a pen and pencil? It's 217-2203. Okay, so just call, someone will pick up. In fact, it's going to be my friend Miss Kelly. She's going to pick up, and she will take your question, and then I'll go ahead and put it on the air. Now, if you're not near the TV or you have to leave the TV, you can get us on the web. You go to, if you look at this, go to http:// so there's no www, at ewtv.org, which stands for eastwaketv.org, and it will prompt you for whether you have a live connection or a modem connection, and you can actually see everything going on right on the web. And if you miss any of this, or you miss a question, or you need to come back to it later, these are all being archived, and you can access them at that same website, okay? All right. Well, I'm going to get started today. I'm going to be working on Algebra 1, Geometry, and Algebra 2. And if you need me to skip around, you just call, and I will jump straight to that problem. All right. So let's get going. Let me start with Algebra 1 problem. And let's look at this one. These are coming from Goal 1, and let me zoom in a little bit. Goal 1, which I don't have in front of me, but I'll find it for you, is dealing with, what has the answers on it? Here it is. Write equivalent forms of algebraic expressions to solve problems, apply the laws of exponents, operate with polynomials, factor polynomials, okay? All of that is part of Goal 1. All right, so let's look at this first one. First one says, let me go in just a little bit more. There you go. Simplify. Simplify x plus 2 times the quantity x squared plus 2x plus 3. Simplify. When it says simplify, it is not asking you necessarily to solve for x. It's just asking you to do the very best you can. Now, sometimes you might end up with a number at the very end, but they're not asking you to end up with something like x equals. You might end up, in fact, if you look at your answers, can you see that your answers, like this one, x cubed plus 7x plus 6, these are working out to be trinomials or polynomials that have, in this case, 4 terms in them. So you're not necessarily solving for x, you're just trying to simplify the expression. There are 2 ways you can do this. You can take your x and kind of do a FOIL through all of them. But I think when you have something that's bigger than a binomial times a binomial, the easiest way to do this is to set up a little box or a matrix of a sort. It's much easier to look at the problem. What I do is I set up, there's the x plus 2 term, and then I'm going to set up the x squared plus 2x plus 3. See, I'm just making a grid. And then what I can do is I can do the multiplication. I can say x times x squared and put that right there is x cubed. Now, you know what? Before I go any further, I've just determined that the very first term is x cubed. Look over here at my answers. This one starts with an x cubed. B doesn't even contain an x cubed. C does contain an x cubed, but it's 2x cubed. And D has x cubed. So you know what? We have already eliminated B and C. Sometimes you can do that. Now, if you look at the rest of our answer, you see how there's a 6 at the end? So some of the things are going to there's a 7x in there. So it looks like a couple of things are going to duplicate. Let's keep going. X times 2x would be 2x squared, and then 2 times x squared would be 2x squared. Now, why did I do it, not go all the way across? Because what's always going to happen is the diagonals are the ones that are going to add up. See that little plus there with the grid? That's why I like the box. So 2x squared plus 2x squared is 4x squared. So that's our second term. So again, without even going much further, do you see that we have just eliminated a because there is no 4x squared and d has the 4x squared? Let's just keep going so we can wrap this up. X times 3 would be 3x. 2 times 2x would be 4x. And see how they get added up. The ones on the diagonal are the ones that are getting added. That gives us plus 7x. And then finally, 2 times 3 gives us 6. There we go. And sure enough, that answer matches D. Good. All right. So take the time. I think this box, especially those of you who might have messy handwriting or when you get flustered on the test, it's very easy just to set up this grid with the box. All right, and then you won't lose track of what you're doing. All right. Now remember, if you have any questions, just give me a call, or if your teacher solved it a different way or you're not sure how to do it, or you want to see that same problem, you want me to solve it a different way, I'll be more than happy to reach into my little hat and see what I can find. All right, second question. This, again, is also coming from Goal 1 from the Algebra 1 test. Each binomial, let's look at the problem. Which binomial is a factor of 3x squared plus 2x minus 5? Whoop, there we go. All right, first thing we have to know is what is a factor? Okay, do you remember what a factor is? Think. What if I said, what are the factors of 10? Factors of 10. Well, the factors of 10 are 1, 2, 5, and 10. Versus multiples of 10 would be 10, 20, 30, and so on. Okay? So what's the difference between a factor and a multiple? Well, a factor is a number that when you multiply it times another number, it gives you 10. But in this case, the factors have to be whole numbers. Why? Because they have to divide evenly into 10. Multiples are if you multiplied them times, like in this case, 10 times 1, 10 times 2, 10 times 3. Those are multiples, so don't mix those up. So in this problem, when it says which binomial is a factor of 3x squared plus 2x minus 5, they're saying, like if we looked at A, we might be saying that 3x minus 1 times something else gives us 3x squared plus 2x minus 5. Now for us to be able to figure this out, there are two ways we can approach it. The best way is to actually factor this trinomial. Okay, so that's the method I'm going to use first. Now if you forget how to factor, there is a way you can get yourself out of trouble. But let's do the way that you probably were taught, which was to factor. So we have 3x squared plus 2x minus 5. Now, factoring is where you have those double sets of parentheses, right? But this one isn't as easy because your leading coefficient is a 3. It's not a 1. So we're going to multiply the first term and the last term, and that would be the a and the c coefficient. And then we're going to take the b term. We're going to multiply the a and the c. So 3 times negative 5 would be negative 15. And then we're going to take the b term, which in this case is positive 2. And now I need two numbers that multiply to give me negative 15, but add up to give me 2. That's why I always call this the times AC plus B method. It's probably actually called a grouping method. All right, so what are two numbers that multiply to give you negative 15, but add up to give you 2? Well, let's see, 5 and 3. Whoa, my goodness, what have I done? All right, everyone, stop standing on your head. Okay, now flip around. Whew, I hate it when I push that button. But makes you wake up over there, doesn't it? All right, so 5 times 3. 5 times 3 is positive 15, so we need negative in there. But look, 5 minus 3 would give us 2. So what if we had positive 5 and negative 3? Positive 5 and negative 3 multiply together to give you negative 15 and add up to give you positive 2. So what we're going to do is we're going to split up our middle term. So we leave the 3x squared alone, and now we're going to add 5x, add a negative 3x minus 5. Okay? Now, A lot of times when you do FOIL method, don't you end up with 4 terms, and then you end up putting the middle 2 together? So that's all we've done. We've just kind of gone backwards. We've split up the middle term. Next step is you group the first 2 and the last 2, and I'm going to rewrite it, but you wouldn't have to necessarily rewrite it. I'm going to group the first 2 and the last 2. 3x squared plus 5x plus negative 3x minus 5. All right, what do we do now? Find a GCF in both of these groupings. What do 3x squared and 5x have in common? Good, they have an x in common, so we're going to factor out the x. That will leave us with 3x plus 5. Plus, what do negative 3x minus 5 have in common? Well, you have to pull out something, so you can always pull out a 1. But you know what? Whenever there's a negative in that leading value, take out the negative 1. Okay? So we're going to factor out negative 1. We'd be left with 3x plus 5. That's exactly what we wanted to end up. Do you see how these 2 groupings match? So you have a term right here and a term right here, both with matching groupings. So factor out the grouping. So we're going to factor out the 3x plus 5 from each of them. And then I always just cover it up, and whatever's left over, whatever's left over is the other grouping, x minus 1. So what have I just found? Well, I have just found 2 factors of the polynomial 3x squared plus 2x minus 5. Well, of those, which one of those match our possible answer? Hold on. Let's go up here. Ha-ha, look at that, instant. All right. So if we come back up, does 3x minus 1, 3x minus 1, that was not a factor. X minus 1, that is a factor. 3x minus 5, ooh, look at that. It's 3x plus 5, that wasn't one. And x minus 5 didn't work. So I just checked them all, but there's only going to be one answer, so it would be B. So what is a factor? A factor that is a number that multiplies to give you 3x squared plus 2x minus 5. Now, what are you going to do? Let me go back down. What are you going to do if you forget how to factor? Well, you could, Algebra 2 people, you better be saying that you'd do synthetic division or you would do long division. You could try to do some guess and check. You know one of these is going to be the factor, so that could be a method of getting yourself out of trouble. But the best way in this case is just you're just going to have to remember how to factor. Okay? All right, good job. Whew. You can do it, okay? Don't panic on the test. You have the tools, okay? Every one of you, algebra, geometry, algebra 2, your teachers have worked with you all year, and you have all the tools to do well on this. Even if there's a problem that doesn't look like an exact problem you've done this year, I bet you've done some variation of it, right? So just step back from the problem, read it a couple times. Maybe you need to skip it and come back to it in a little bit. That's okay. Just back off. You've got enough tools to get through each and every one of these problems and ace these tests, okay? You can do it. All right, let's look at problem 3. Problem 3, again, this is the Algebra 1. Says simplify 14c cubed d squared minus 21c squared d cubed, all divided by 14c d squared. Whew, spit all that out. All right, so I'm going to rewrite it over here so that I can play with it. 14c cubed d squared, I don't know why that's so hard for me to say today, 21c squared d cubed, all divided by 14c d squared. All right, so if we get in there, we can let these 14s cross off. Here's a c with this one. That can be a c to the 2 now. D squares cross off. So there's our final answer, right? C squared minus 21 c to the 2 d to the 3. And is that one on there? Well, this one's pretty close, so maybe it's C. Nah, it isn't. Oops, here. It isn't C. And why is that? Well, you know what? I did this completely wrong. When you have a numerator, you have a denominator, you don't split up the family. You got to keep the family. So in our original problem right here, don't split up the family. You want to give something to the family, you got to give it to every single member of the family. Can't be doing this, giving it just to one group. You got to give it to everybody. So let me rewrite this problem, huh? If I was to rewrite this problem keeping our families in mind, I would say 14c cubed d squared divided by 14c d squared minus 21c squared d cubed divided by 14cd squared. You have to give it to both. When I say give it, I mean you have to give that denominator to both parts of the numerator. So now we can do each one like a separate problem. The 14s cancel. There's 3 c's on top and 1 c on the bottom. That leaves us with c squared on the top, and the d squares cancel, meaning really they just divided through. Minus, now what number goes into 21 and 14? 7. 7 goes into 21 3 times. 7 goes into 14 2 times. 2 c's on top, 1 on the bottom. Cancel, leaves you with 1 c on top. 3 d's on top, 2 d's on the bottom, leaves you with d to the 1. Now let's see what we have. We have c squared, nothing left in the denominator, minus 3c d to the 1 all over 2. Now, does that answer represent a little bit better? Let's look over here. C squared, so we've lost those two now. So it's between A and B. Then it has to be minus, we got that. Let me zoom out just a little bit. There we go. We're trying to get it to match this problem answer right here. So 3cd over 2, there it is, 3c squared d over 2, okay? So they're trying to trick you. So the answer is A, okay? So what are they looking for? They're looking to see that you accidentally did what I tried to trick you right here and only divide the denominator into one of them. You need to divide the denominator into all the parts of the numerator. Even if there were 20 of them, you can do that, okay? And that's just following a basic rule of fractions. If you recall, if you had something like, oh, I don't know, 2/7 plus 3/7, you would add the numerators over the denominator, right? So you'd have 2 plus 3/7, which would be 5/7. But sometimes, now that we've gotten good with fractions, we have a tendency to miss that middle step. Well, in algebra, you're doing all that same arithmetic that you used to do in elementary school, except now you're kind of doing it backwards and forwards, and you're doing it with numbers you don't know, like variables like x. It's a number, it represents a number, you just don't know what to do with it. Okay? All right, so be very, 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 very careful. All right, let's try one more from the algebra. Did we got a call? Does somebody want something? You're looking for it. Okay. All right, let's look at this one. Find the image length of L of a 4-foot tall object in a spherical mirror with a focal length of 2 feet. L, can you see that? Let's get zoom in a little bit. There's a lot of words in this one. Boink. There we go. L equals 4 times the quantity 2 over 0 minus 2. And that's not 0 really, that's O. Can be used, where O is the distance in feet of the object from a mirror. All right, now at this point, several people might be thinking, oh my gosh, I don't know anything about optics. I've never learned this formula. I don't know what I'm supposed to do. Have faith. Let's get all the way through it. What is the image length of the object when it is 1.5 feet away from the mirror? Okay, look what this formula is doing for you. The image length, or L. Okay, so what is the image length? So what is L? And they said of a 4-foot tall object in a spherical mirror with a focal length of 2 feet. All right, those are constants. That's what's just in the formula. Where O is the distance in feet of the object from the mirror. Well, look. The object when it is 1.5 feet away from the mirror. This problem has nothing to do with you doing anything with this formula except plugging in, and I shouldn't say that, but you know exactly what I'm talking about, substituting in 1.5, plug and chug. Don't get nervous, look at me, don't get nervous if you get a formula that's unfamiliar to you. They will give you enough information for you to use that formula in the context, okay? Now, geometry, you're going to have to memorize a lot of formulas. In algebra, there are some formulas you need to memorize. You need to memorize your distance formula and midpoint formula and some of your basic like area and perimeter formulas. Don't get me wrong, you're going to have to memorize those. But if they give you a unit or they give you a formula that's not familiar to you, the problem is most likely not about can you work this formula. It's probably about can you simplify the formula. Okay, let's look at this one. Let's finish this one up now. So really all we want to do is put 1.5 feet into this formula. So let's see what we can do. L equals 4 times 2 over the distance, 1.5 minus 2, close parenthesis, squared. Now, the only thing I would be very careful is if you type this into your calculator, in fact, let me type it in. Look what we can do. We could say 4, let's switch over, there we go. 4 times, open parenthesis, 2 divided by 1.5 minus 2, close parenthesis, squared. We hit enter, we got about 1.7. And if we come over to our answers, that's not even a choice. And actually, I'm very surprised it's not a choice. All right, so what did I do? Well, let's go back to the problem. And you can't see both of what's going on, but in my screen, let me write it up here. On the screen, this is what I typed in. 4 times 2 divided by 1.5 minus 2 quantity squared. Well, here's the problem. If we did order of operations, what's going to happen first? It's going to go inside this parenthesis. You guys, it's going to do this division right here first. And that's not really what we want. We want 2 divided by 1.5 minus 2. Okay, that's a little bit different. So you need to put an extra set of parentheses in. Or to be honest, what I'd recommend is deal with the parenthesis like a separate problem, then come back and put numbers in. You cannot afford to get any problem wrong on the test. So 4 times 2 divided by, what's 1.5 minus 2? Well, negative 0.5 squared. Now you just have some simple numbers. That is much easier to plug into the calculator. So what we could do is we can do that same problem, or I'm going to do the simplified version now. 4, and then I'll show you how to do the long way. 4 times 2 divided by negative 0.5 quantity squared. Oop, oh my goodness, what did I do? Oh, that parenthesis. I didn't open a parenthesis, so I have to go back 4 times. Let's insert a parenthesis. There we go. Now enter. 64. So is that one of our choices? Sure is, 64. Now, using the original way, let's go back to our problem again on the calculator. If I was to type it in the original way without simplifying that expression first, I would say 4 times, open parenthesis to get the fraction, so 2 divided by, open the parenthesis to get the denominator, 1.5 minus 2. That takes care of the denominator. Now close the parenthesis to deal with the fraction, then square it. And sure enough, we got 64. So be very, very careful. Order of operations is going to be maintained even on the calculator. Just take your time and do part by part. It'll save you some steps. Now, since you've got pretty much, you've got a lot of time, you can take this test, I believe. So take the time that you need to get each question right. And if you're not quite sure, skip it, circle it, something you want to come back to. Okay, good. All right, so again, don't panic if you get one that's not quite, it's not quite something that you're looking for. No, that didn't make sense. It made sense in my brain, but not what I was saying. Don't panic if you get a formula that's not what you're used to, and you're looking to solve it. So in this case, you were just looking to substitute in values. That makes sense? Just call me if that didn't make sense. Okay, here we go. We have a call from Kelsey in Algebra 2 from Southeast Raleigh High School. Hi, Kelsey. Solve for x. So looking at this problem, we have, make sure we're on the screen, there we go. We have 3x squared, 3 over x squared plus x minus 2 plus 3 over x minus 1 equals 1 over x plus 2. First thing I would do, protect my family. I don't want to take a chance that I'm going to start crossing things off. So when we add fractions, the very first thing, or there's 2 ways you can go with it. You can find a common denominator, and we can make all of these with common denominators and then add their numerators together. Or one of the other things you can do is you can just multiply through by the common denominator and eliminate the fraction altogether. So let's go ahead and factor out this trinomial right here to be sure that we know what its factors are. And this is a quick one to factor because that leading coefficient is 1. So we split up the x. X times x is x squared. So what are 2 numbers that multiply to give you negative 2? Well, that would be 2 and 1, but we need to end up with add up to give positive 1. So it would be positive 2 and negative 1. All right? So that's what that simplifies. Well, look at this. You've got x minus 1 and x plus 2. So those are all over the place. So what we really want to do is take this problem. Let me go wider, a little bit wider. So we want to take this problem and we want to multiply. Grab some paper. There we go. We want to multiply the whole problem by x plus 2 and the whole problem by x minus 1. That, I think, is one of the easiest ways to do that. So let's take everything and multiply it through by x plus 2. That leaves me with, and if we look at the first term, the x plus 2's cancel. That leaves me with 3 over x minus 1. Of course, now you can't read my handwriting. Let's go wide again. It's a vicious cycle, isn't it? Okay. And take the second one, 3 times x plus 2 over x minus 1. So that leaves us with 3 times x plus 2 over x minus 1 equals, and this x plus 2 and this x plus 2 cancel. It's a family, don't forget, so we're left with 1. All right, now we're going to multiply the entire system by x minus 1. The first term divided by x minus 1, well, those cancel, so you're left with just 3. In the second one, we have x minus 1 in the denominator. That cancels with this. Remember, this is like over 1, so we're left with 3 times x plus 2. And in this last one, there is no denominator there, so you're left with 1 times x minus 1. Now, I don't know about you, but this problem right here, 3 plus 3 times the quantity x plus 2 equals 1 times the quantity x minus 1, looks much easier to solve than this original problem with you had 3 over, oh my gosh, look at this. You know what? These are exactly the same problems. Exactly the same. We've just simplified it to make it look like we want. And that's the fun of algebra, is that you can just keep manipulating the problem. All right, so now if we're going to go ahead and solve this for x, that was our directions, we need to go ahead and distribute our 3 here, distribute our 1, which won't be too much of an impact, and solve for the variable. So we have 3 plus, distribute, we get 3x plus 6 equals x minus 1, because that 1 didn't do anything for us, right? Let's get our x's on one side and variables on the other, so I'm going to subtract x from both sides and combine my similar terms. So I'm left with 2x plus 9 equals negative 1. Let's subtract or add a negative 9 to both sides. I'm left with 2x equals negative 10. Divide by 2 on both sides. We're left with x equals negative 5. X equals negative 5 is choice B from where? All right, so x equals negative 5. So Kelsey, did that come from one of your problems? If it did, but there you go. The answer is x equals negative 5. All right, look good? All right, thanks, Kelsey. If that didn't make sense or it did make sense, just give me a call back, okay? All right. All right, so let's go on with which one? Got another call, Southeast Raleigh. You got your finals coming, don't you? You're kind of hitting them before everybody else, aren't you? So you don't have as much time left. All right, so Megan, Algebra 2 at Southeast Raleigh High School. Let's come down. There you go, Megan. Solve the square root of x plus 5 plus x minus 3 equals 4. All right, well, the very first thing you need to look at is look at these radicals. Whenever you solve a problem with a radical in it, you need to try to eliminate the radical. Well, to do that, you're going to have to get a variable, or I'm sorry, you're going to have to get a radical on one side or the other. So that's what I would do. So first thing I'm going to do is subtract radical x minus 3 and take it to the other side. So we have x plus 5 equals 4 minus x minus 3. All right, so now we've got this radical all by itself. So the first thing we need to do then is how can you eliminate a square root? Well, to eliminate a square root, can't you square it? You sure can. So what if we square both sides? All right, if we square both sides, we're left with, well, a square root squared, you're left with the family that's underneath, x plus 5. And over here you're left with, well, 4 minus x minus 3 squared, well, that would certainly just be 16 minus x minus 3, right? No. You can't take that 2 and distribute as long as you've got that minus sign. And they're going to count on you doing things like that. You need to think about what this really means. This means 4 minus the square root of x minus 3 times 4 minus the square root of x minus 3. All right, now let's simplify. Well, how do we do that? We're going to FOIL. And you can FOIL or you can do the box, whichever one is easiest for you. I'm going to go ahead and FOIL this time since I used the box last time. So 4 times 4 would be 16. 4 times negative square root of x minus 3 would give me negative 4 radical x minus 3. Kind of treat that like a variable, correct? And wait a minute, I need some more paper up here. I'll run off my screen. There we go. Now we have negative x minus radical x minus 3 times 4 leaves us with another negative 4 times x minus 3. And then radical x minus 3 times radical x minus 3, well, a radical times itself would leave you with the family underneath. All right, let's simplify this side a little bit if we can. We have 16 and a minus 3. So 16 and a minus 3 would be 13. And then we have an x that's just kind of hanging out. So plus x. And then we also have negative 4 radical x minus 3 and a negative 4 radical x minus 3, which is a total of negative 8 radical x minus 3s equals x plus 5. Whew, all that just to get to that step. All right, well, we're not done, because now what do we have to do? Well, we still have a radical in the problem. If you still have a radical in the problem, you need to get everything else over to the other side except that radical and deal with that. Okay, so let's do that. Subtract 13 from both sides, and we're going to subtract x from both sides. So x from both sides and 13 from both sides, those cancel. Those cancel. So we're left with 15 minus 13 is negative 8 equals negative 8 square root x minus 3. Oh, that's starting to look very pretty, isn't it? Divide both sides by negative 8. We're left with, we're left with 1 equals the square root of x minus 3. All right, so now how do we eliminate that radical? Well, we square both sides. Square both sides, you're left with 1 squared, which is 1, equals a square root squared, sorry, there we go, is the family underneath. And now we can finish this up by adding 3 to both sides. We're left with x equals 4. X equals 4. Now, I would caution you, and you always need to be careful of this, is that sometimes, if we go back to our original problem up here at the top, sometimes when you have more than one x appearing in the problem, some of your answers cannot work. Now, most of the time that happens when there's an x on the inside and the outside. But you know what, just to be sure, especially if one of your multiple choice answers is none of the above or no solution, take the answer you just got, which was 4, and substitute it back in to make sure that it works. So here's our check. Let's see if it works. The square root of 4 plus 5 plus the square root of 4 minus 3, does that equal 4? 4 plus 5 is 9, so the square root of 9 is 3, plus the square root of 4 minus 3 is the square root of 1, which is 4. Sure enough, it works. And check. All right, so be very careful that you don't end up with, what is that called, Algebra 2? Extraneous roots, right? Nice big SAT word. Extraneous, okay? All right, so who was that again? Let me see. Megan, I hope that helped, okay? The other thing, actually, let's backtrack. If this was a problem that was on the test, we went through all the work. Look over here again. We went through all this work to get to it, but if this was a problem on the test, they're going to have choice A, B, C, and D. One of them is going to be 4. So what you could do if you weren't quite sure how to solve this problem, if this was a problem in the EOC, you could just take A, B, C, and D, whatever those choices were, substitute them in and see which one works, okay? Because only one answer in this case is going to work. Now, if they had double answers, sometimes you'll have 2 solutions, that sort of thing. So just double check. If they have one that has 2 solutions, don't panic. You could have 2 solutions, okay? That's okay. All right, Megan. Very good. All right, so I'm going to keep going. What is this one? Geometry. We're back. All right, geometry. Did I do that one? Oh, that's coming. All right, geometry. Wait, come back, geometry. Must talk to you. Very important. Come back. Come back to me. All right, geometry. This is very, very important. You know, during the test, they're going to be saying, would everyone please, be sure that you have your number 2 pencils. Or welcome today, you're now taking the EOG for geometry. Everyone who said I would 2 number 2 pencils, raise your hand if you don't have 2 number 2 pencils. And you used to fill in the dots, but I would say most of these questions all have, you've all had pre-slugged in bubble sheets. This is what I want you to do, and this is very, very important. This geometry EOC does not have any rulers, any protractors, no types of measuring devices whatsoever. And in a course that was entirely devoted to exactness and measurement, you get no measuring tools, okay? All right, first thing, that's all right. We can deal with that. One of the things they're going to give you is graph paper. Pre-assigned graph paper, look at here on the sheet. Graph paper, flip over, hold on. Graph paper, see down at the bottom? And of course, graph paper. It'll be the standard graph paper that they assign you. You can have as much graph paper as you want, and they're going to start you off with 2 sheets, but you know what? You're going to use those 2 sheets first off. So the next thing I want you to do is raise your hand and get some more graph paper. And what I want you to do is take the very first sheet, and while they're asking you, do you have your number 2 pencil, and you're paying close attention to all of that, and did you get your answer sheet, and does your answer sheet color match your test booklet? I want you to take one of those and I want you to fold it in half, or cut it in half. Then I want you to take it and look over here on my screen. I'll do it on here so you can see. I want you to take it and I want you to fold it. Don't get carried away about how you fold it. I simply want you to take it. Can you see what I'm doing? Let me put it on white paper. There we go. I'm just folding it over. Don't fold it like a fan. Fold it like a sleeping bag. Fold, 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 fold. There it goes. Folding, folding. It wasn't perfectly neat, but that is okay. Look at that. See, I did that? All right, let's do it with the other one. Ready? Let's try again. You're so good at it, we can do it again. Fold, 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 fold. Look at that. 2 sleeping bags. We're ready to go camping. Fold, 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 fold. Okay? All right, so what have I just done? Well, I have just created 2 what I'm going to affectionately call cheaty rulers, okay? Because what we have just done, if you look back here on the screen, is if I have something, if you think about what a ruler is, get the white, there we go. If you think about what a ruler is, let's zoom in. A ruler is something that's been calibrated, correct? Sometimes it's wooden, sometimes it's metal. Well, this one's made out of paper. And this one has been calibrated by, I think these are probably centimeter blocks. It doesn't matter, but they're all been calibrated equidistant apart. So a couple things are going to happen. This ruler is going to allow you to do several things. It's going to allow you to draw straight edges. And if you draw a straight edge on both sides, you've got parallel lines. It's also going to allow you to create segments that are, let's say, 5 units in length. So I could say, okay, start here, 1, 2, 3, 4, 5. And I could create another one, 1, 2, 3, 4, 5, 6, 7. And pretend that those were the bases of a trapezoid, which I'm going to call that one 5 and that one 7. So you can redraw your shapes to scale using this cheaty ruler. One of the other things you can do is if you take it, and if it's too thick, you can always break it down, but take it and fold it. Okay, the fold that I just created right there is what? The fold I just created right there is a 45-degree angle. Okay? So I can create perfect 45-degree angles, and I can pull this one over, and now I have an isosceles right triangle. If I do 2 folds with it, and that's why I want you to have more than one of these, because I want one that's been folded up. This one's kind of thick, so I almost would have cut this paper twice. But the angle that was just created here, when I do a double fold, you see that? It's kind of like when you fold your paper and you're making a football. Got a perfect right angle there, okay? And of course, you wouldn't have something as thick as my pen. So you've got a perfect right angle. So if you have something that you need to create a right angle, or you need to measure it and see if it is, especially on the coordinate system, that's going to be the point that I'm getting to. You have the tool in front of you. Now, the other thing you can do, and I need to find something I can poke with it, and I'll do that in a second. But if I poke a hole, do I have a pen? Here we go, perfect. Now, you're not going to be allowed to have, look at me. You're not going to be allowed to have, I have a paper clip in my hand. You're not going to be allowed to have a paper clip on the EOC. So what I would recommend is get one of those clicky pencils where they're hard, the tip is hard, and you take it and you punch a hole. See if I can do it without punching through to my finger. Patience, this is worth it. Okay, so punching through, punching through. If it doesn't work, you know what, let me just make this a little bit thinner so it can go through, see? And you're allowed to cut paper. There's nothing on the EOC that says you're not allowed to rip paper. You just can't rip the test booklet. There is something that says you can't rip anything out of the test book. All right, so see, I punched my, well, you can't see it, but trust me, I punched the paper clip through, which you're going to have a pencil. So punch it through and make a hole, and then do that twice. Why am I doing it twice? I'll show you. Let me get it through. Let me get it through. I just don't want to poke through myself. There we go. All right, I poked through. Now, I should have 2 fine tip ones here, and you're going to have 2 pencils. Why? Because you're supposed to have 2 number 2 pencils. It's the rule. Have 2 number 2 pencils. All right, so what do we do? All right, come over to my paper. I now have 2 holes in my paper. Stick one of your pencils in one, put one of your pencils in the other, and look. You have a perfect compass. So if you'd punched different holes, let's say we'd punched another hole another 2 centimeters out, you would have had you could have made concentric circles, and you could have drawn. Now, what's going to happen is on the test, they're going to say, you have a circle whose diameter is blah, blah. Okay, so mine, the diameter, or my radius was 1, 2, 3, 4. So now I know my diameter is 8. So you can draw nice circles. Look back at me. You can draw some nice circles that are to scale. The better you can make your drawings, the better you can represent your problems, okay? So now what do you have? You have a ruler, you have a compass, you have a protractor. And if you practice with, here you go. you practice with some of your folds, you can get some of your other angles if you really want to. But that's normally enough to get you what you need, okay? So what you're going to do, you're going to take one of your pieces of paper, you're going to make a cheaty ruler. There's one more thing that's really good about this. And I know you're thinking, oh my gosh, please be quiet. This is really, really important. Let's pretend, we don't have to pretend too hard. We'll go back to my graph paper. Let's pretend one of the problems they say, okay, you have a triangle with the following coordinates. 2, 1, 2, 3, that's point A, and 5, 6, so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, and 7, 1. Or no, we'll go a little bit wider. We'll go 9, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. We'll call that C. Now, once you draw it on the coordinate system, use the straight edge. The more exact, the better. The more exact you are, the better. Use your straight edge. Here I am creating my triangle. And mine's bleeding a little bit. That's just because I'm using a permanent marker. You can't use a permanent marker. All right, so there's my triangle. Now, what if they asked you what type of triangle is that? I am not saying I don't want you to know the distance formula. You certainly have to know the distance formula. But if they asked you what type of triangle that is, you can take your cheaty ruler, because your ruler is calibrated just like your graph paper. And you can get at least an approximation measurement to see what type of triangle this might be. So this is 1, 2, 3, 4, 5, 6, 7, and then some. So I'm going to say this is about 7.5. Let's see if that's going to be enough for me to figure out what type of triangle this is. If I measure from A to B, that's 1, come on, 1, 2, 3, 4, and then some. So I'm going to call this 4.5. And then the last one, BC, 1, 2, 3, 4, 5, 6, 6, and then some, so we'll call that 6.5. It is calibrated enough that you do not have to do anything but measure that, and you would know this is scalene. Now, the other thing you can do, if you were nervous about that, then you know, you can see that these are the two that are going to be close. It might be close to an isosceles. It's definitely not equilateral, right? Correct? Is it a right triangle? Well, you have a perfect right angle. The coordinate system will not lie. So is that a perfect right angle? No, it's not working at all. You have to tilt it. So it's not a right angle, but you would know that if you were close and you were nervous about it, these would be the two that you could test for slope, correct? That looks pretty good. The other thing you're allowed to have on the test is an overhead, or I'm sorry, colored acetate. Now normally the color acetate that your teachers have is clear, which is like an overhead. And you're allowed to have a highlighter. So if you had a piece of acetate, which you can see through, and I'll bring some next time, and you had an overhead, you could actually trace this triangle and rotate it and see what the lengths were and put them right there on the coordinate system and measure your units over, okay? It's very, very powerful. Now, something else that you can do is one of the other things, look back at this picture, and I know we're going to get to problems like it, but I just need to get all this out of my system, is sometimes they say, what is the equation of the line that is the perpendicular bisector from C to AB? Well, perpendicular bisector, well, actually it wouldn't necessarily go from C. Why don't we call it the median? So median would go to the midpoint. So how can you find the midpoint of that? Well, you know what? You can take your paper and you can poke through. And this is much better if you could see through it. But you can poke through, and then you can put them right together. And I know this seems like you're taking a lot of time, but it only takes you a second. Look at that. I just found the midpoint. Physically, it's all done. I just folded the paper, put A and B, made them kiss. There's my midpoint. So from there to C, what is the equation of that line? Well, just looking at that, can you tell me something about the equation of that line? Well, you can say that it has negative slope. You know that much. Its y-intercept is 1, 2, 3, 4, 5, somewhere between 6 and 7, somewhere around in there. So you might be able to narrow things down. So the nice part about this is that using just the graph paper and using a ruler that's calibrated, you might be able to find some of your answers if you forget how to do your distance formula and do your midpoint formula and do some of your other equations, okay? You can always get yourself out of trouble. The coordinate system's not going to lie if you've been very exact, okay? All right. So what are you allowed to have in the test? You're allowed to have graph paper. They're going to supply you graph paper. They're going to supply you blank white paper, which sometimes you can kind of see through to retrace. You can have colored acetate. So ask your teacher what color that they might provide. Most of the time the teacher can provide clear. And then you be sure you get a highlighter, because you're allowed to have a highlighter that you can that'll work on clear or whatever color they get so that you can redraw some of your pictures, okay? So you've got a compass, you've got a ruler, you've got a straight edge, you've got it all, baby. Back to our regularly scheduled program. Problem 5 on geometry. And you can't see it because I zoomed out too far. Oop, there's my circle in the background. There we go. A point is randomly selected on segment XY. What is the probability that it will be closer to the midpoint of XY than to either X or Y? All right, well, first of all, let's draw a segment that would represent. So there's a segment. And I just drew it using my cheaty ruler because I wanted it to be straight. So it says, what are the chances if a point is randomly selected on XY, that the probability that it will be closer to the midpoint of XY than to either X or Y? Well, the midpoint will be, say, about here. We'll call that M. So the question is if I randomly pick a point, let's say I pick a point right here. Let me use a different color. If I pick a point right here, is there a chance that it's closer to the M or closer to the X? Or what if I pick a point right here? Is it closer to the M or closer to the Y? When you do probability with segments, you need to divide them up. So if we took this and divided it right here, that gives us 2 equal halves, but that's not going to help us decide whether it's going to fall closer to the X or the M. So when is it going to fall closer to the X? Well, at the halfway point, if the point is on this side, it'll fall closer to the X. I don't know if you can see now. Ooh, there we go. And if the point falls on this side of the half, you're going to fall closer to the M. Also, if I hit the midpoint of MY, if the point falls right in here, it's going to fall closer to the M. If the point falls on this side, it's going to fall closer to the Y. So what have we done? We've taken segment, should have used my straight edge, shouldn't I? We've taken segment XY. We know M is in the middle, and I've created 2 other points on there. So how have I divided it up? I've divided it up into perfect fourths. So when you get probability, you will hit the point. That's important. Or, I'm sorry, you will hit the segment. So you're guaranteed to hit the segment. You close your eyes, boom, you point. Well, I happen to hit right here, so that put me closer to the M. So how many times will it be closer to the M when it's in this range right here? So 2 out of the 4 blocks are closer to the M. 2 out of the 4 blocks are closer to M, or half the time. Choice C. So the hard part about this, come back. Hard part about this one is you need to be able to decipher what the question is. Now, what's this 1/4 looking at? This 1/4 is looking at the way we'd partitioned it into fourths. 1/3, I'm not sure where 1/3 is coming from, except that maybe they thought you had 3 points and you divided it up. Maybe they thought that meant you divide it into thirds. And no idea where 3/4 is coming from. So a lot of times your answers will be very close or very similar to what you're working on. Okay? All right, what's this one? Algebra 1? All right, Algebra 1, we're back to you. Oops, went too far. There it is. Oh my goodness. All right, well, do your best. Get up to the screen, okay? On a map's coordinate grid, Panthersville is located at -3,2, and Heel City is located at 4,8. Falcontown is the midpoint between Panthersville and Hill City. That's hard to say, read out loud. What is the approximate distance from Panthersville to Falcontown? 1 map unit equals 1 mile. All right, so since this is a coordinate problem, what are we going to do? We're going to get out our coordinate paper. They're going to give you graph paper. In Algebra 1, you saw me just go through that whole ruler mess. Do it. Make a little cheaty ruler. All right, so let's make our coordinate system. Since now I have a cheaty ruler, I shouldn't call it cheaty, but you know what I mean. We made one all by ourselves. And there's nothing on the test that says you can't fold paper, except the test booklet. So fold away. All right, so let's get down our points. So Panthersville is located at -3,2. So 1, 2, 3, -3, +2. I'm going to put a P there for Panthersville. And Hill City is located at 4,8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8 is Hill City. Falcontown is the midpoint between Pantherville and Hill City. What is the approximate distance? So somewhere in between these is Falconville. Falconton. What was my ville? My ville is Panthersville. All right, so what should you do? Well, algebraically, we want to find the value using midpoint. Find out where Falconton is, so that would be the midpoint. So somewhere in here is the midpoint. So first we need to find the midpoint of, in this case, PH, which will be Falconton. We'll call it F, okay? Then once we find where Falconton is, then we have to find the distance from Pantherville to Falconton, which would be the distance formula. So then we're going to do the distance of, or the length of PF. All right, so let's tackle that. And then I'm going to show you how to do it faster. So first we're going to find the midpoint. So what were our original coordinates? Were -3, 2, and 4, 8. Algebra 1, you've got to know these formulas. Algebra 2 and geometry, you need to know these formulas. So what is midpoint? Midpoint is the sum of the x coordinates divided by 2 and the sum of the y coordinates. It's the average. So -3 plus 4 divided by 2 and 2 plus 8 divided by 2. All right, what's -3 plus 4 would be +1, so that would be 1/2. And 2 plus 8 is 10. 10 divided by 2 is 5. So our midpoint is at the point 1/2, 5. So if we go over 1/2 and up 1, 2, 3, 4, 5, yep, that looks pretty good. All right, so there's F. So the next question is now, what is the distance between P and F? So you need to know distance formula. Distance formula is the change in x squared plus the change in y squared. Geometry, you have to know that still. All right, and so what does change mean? Change means subtract. So let's subtract our coordinates. So -3 minus 4 squared plus 2 minus 8 squared. So -3 minus 4 is -3 plus a -4, which is -7 squared. Plus 2 minus 8 is -6 squared. So that's 49 plus, did I do something wrong? No, that's right. 49 plus 36, which is what? I did wrong. Oh, you know what I did wrong? I'm finding the distance between P and H. See what I did? I need to find the distance between P and F. So here's my F right here. Let's try that again. All right, try that one more time. So we need and you know why I should have always marked myself DF, or I'm sorry, PF. So I remember what I'm doing. All right, so again, the difference of the exit would be -3 minus 1/2 squared plus 2 minus 5 squared. Is that better? All right, so 3 minus 1/2 would really, -3 plus a -1/2 would be -3.5 squared plus 2 minus 5 would be -3 squared. So 3.25 would be 12.25. -3.5 squared is 12.25 plus 9, which is approximately, and remember all these are under the square root, which is about the square root of, well, 9 plus 12. We can do it exactly. Let's pop over to your calculator. 12.25 plus 9 is 21.25. Take the square root of that, square root of our answer, back on the calculator, there we go, is equal to approximately 4.6. 4.6 what? Well, it's approximately 4.6 miles. So if we come over here to our choices, let's get all this mess off of here. There's our choice, B. All right, now you want to see something cool? Let's go back to where we were. Watch how fast I can do this. Sometimes you don't need to do all that. I'm not saying not to do it. Sometimes you really are going to have to, if you forget your formulas, you can do this. So 1, 2, 3, 1, 2. There's P. 1, 2, 3, 4, 5, 6, 7, 8. No. 4, 1, 2, 3, 4, 5, 6, 7, 8. There's H. If I use the straight edge, okay, so I just duplicated what I had before. How long is that? It's approximately 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units in length. So half of 9 units would be 4 1/2. So 1, 2, 3, 4 1/2. That puts our midpoint right there. How close was that to our original? Pretty close, guys. It's right there, right on target. So then the question is how long is from F to P? It's about 4 1/2 using our Cheaty ruler, okay? Now that's not exact. We know the exact answer now is what, 4.61? But look over here at your numbers. .25, well, for it to have been 3.25, that means the whole length would have had to have been 6 1/2, and this is definitely longer than 6 1/2. If it was C, 5 miles, that means the whole length had to be 10. This is definitely less than 10 units. 9.22 miles would imply that's the whole length of PH. Or I'm sorry, 9.22 is saying that's the length of PF, which means the whole length of PH would had to have been over 18. This is definitely not 18 units. So even just by using this elimination method and touching it using the Cheaty ruler, the closest one you can get is 4.61. This is also a method you can use just to check your work to see how close you were in case your numbers were off. Okay? All right, so just something to think about. All right. Next problem. Isn't that neat? It is. Can't rely 100% on it, but it's a good way to check, and if you're running out of time, it'll also give you a good idea as to whether answers are falling in which quadrant. Maybe they were giving you a coordinate, and our midpoint was definitely in the first quadrant, right? So you know you were looking for a positive, that sort of thing. All right, let's look at number 4. Back to algebra. This is goal 2 now. And goal 2, do we have the answer sheet? What's a goal 2? Well, I'll find it for you. Goal 2, just looking at the problem, must have to do with solving equations. There we go. There we go. Goal 2. Oh, wow. Use the parallelism or perpendicularity, whoo, those are nice big words, of lines and segments to solve problems. So we're using the concepts of perpendicular and parallel to solve problems. So just to make sure we understand, if two lines are parallel to each other, if line 1 is parallel to line 2, what is the one thing you know? Well, slope 1 equals slope 2. What do you know if two lines are perpendicular? If line 1 is perpendicular to line 2, then what do you know about their slopes? Slope 1 times slope 2 equals -1. And that's a fancy way of saying that they are opposite reciprocals. So if slope 1 happened to be 3/2, then slope 2 would be -2/3. And if we multiply those two numbers together, we certainly get -1. Now, geometry, you've been working a lot with the coordinate system and your transformations. That should make sense to you now, that if you have two lines, let me just pull this back up real quick. If you have two lines on the coordinate system that are perpendicular, the negative made it change slope, and then how do you get that reflected piece right there, right? You have to change your x and your y. So that's something you've been working with, so that might make more sense to you now. All right, so let's see where this problem is taking us, now that we remember those two rules. Which of the following is an equation of a line perpendicular to 3x plus 6y equals 12 and passing through 4, 0? Well, a couple key issues. We have a line perpendicular to our original line. So this is line 1 that's on the screen. So things that we need to know then are, first thing we need to do is find slope. So if line 1, let me rewrite it, is 3x plus 6y equals 12, what would be the slope of that line? Well, in standard form, ax plus by equals c. Slope is represented by taking the opposite of the a coefficient, opposite of the value in front of the x, over the y coefficient, so opposite of a over b. So in this case, the opposite of a over b would be -3 over 6, which is -1/2. -1/2. So now let's look at our possible answers right now. A has a slope of -1/2, so is that it? Well, what does perpendicular mean? Perpendicular means they're going to be opposite reciprocals. -1/2 means Let me zoom in a little bit. We're talking about it. This will be it now. Negative 1/2 means the lines are parallel. So in part A, they were counting on the fact that you forgot to do opposite reciprocal. Look at B. B is positive 1/2. Well, no, the slope we're looking for, that's not the opposite reciprocal. That's negative. It's opposite, right? But it's not the reciprocal. So they're counting on the fact that you did one rule, but you didn't do the other. What about C? C is negative 2x. The opposite reciprocal to negative 1/2 is 2 over 1, but positive 2 over 1. So in part C, they're counting on the fact that you did get the reciprocal, but you didn't change the sign, which leaves us with part D, y equals 2x minus 8. What is the opposite reciprocal of negative 1/2? Positive 2 over 1. We multiply those together. Sure enough, we get negative 1. That's what we're looking for. There's our answer. Notice how they gave you all the possibilities, though, right? So you have to be sure that you have each one of your rules. Did we even need to deal with the fact that it was passing through 4,0? No, we did not. But you could type this into your calculator if you wanted to. You could type this in the y equals, and you could see that it passes through 4,0. And I'm going to let them make me go over 1 minute, so look at your calculator. I go to the y equals, and I'm going to type in 2x plus 8, and I'm going to go ahead and graph that. So there's my graph. Now look at your table, which is second graph. Is the point 40 there? Oops. What did I do wrong? Did I type it in right? Oh, minus 8. Whew. Got me nervous there. There it is, minus 8. There's our graph. Is that better? Much better. Okay, so now go to our table. See, that was a good way to check myself. Go to 4, and sure enough, there's the point, 40. So that line passes through that point. Whew. All right, so even myself, when you type it in, that was a good way for me to check myself because it didn't work, and that was just another way to check yourself to see. And I just typed it in. Okay. All right, well, that's all the time that I have for today, but we're going to be here tomorrow from 4 to 5, same bat time, same bat channel, to go over some more EOC questions. And don't hesitate to email me as well. I had an email address that you could email it, which I don't know what I've done with it right now. It's at the bottom of my pile. Here we go. You can email me as well if you have some questions at, go wide. I'm sorry, have I gone over too far? We're okay? There we go. At mathhelp@wcpss.net. And you can email your questions there. If you have something specific you want me to go over, I'll be more than happy to go over that with you, okay? Also, email me some feedback, how we can make the show better for you next time, okay? All right, well, thank you so much. Have a great night. Bye.